Hi, everyone. My name is Chaozhe He. I'm assistant professor at University of Buffalo. Together with me is my colleague Austin Angolo, also from Buffalo. Today, it's great pleasure to share some of the research we have been doing with Mcity and provide you some update about and also our vision. So first, we start with the team. So the two of us representing a team of 4 faculty and the students who have very diverse background. Myself is mechanical and aerospace engineering. My expertise is more on vehicle control, connectivity, how to model human behavior and planning accordingly. And with Dr. Austin Angulo, his expertise is really about virtual reality. And we have also Dr. Irina Benedict, who focus on transportation, human factor. And finally, last but not least, Dr. Kevin Hume, who is an expert on gaming simulation, vehicle dynamics simulation, and so on. So we really have a diverse team that allows us to bring the next level of simulation virtual reality for the safe and testing of connected automated vehicle. So next, I would like to turn to my colleague Austin to introduce some of the facilities we have complementary to Mcity.
Hey everyone, thank you again for having us here. We really appreciate the opportunity to talk about the work that we've been doing, and it's also wonderful to see so many of you that we've been talking with virtually, finally in person. As Chaozhe had mentioned, my name is Austin. I'm the director of our Transportation Research and Visualization Center at Buffalo, or we call it Travel. You can see it right down there, Travel. So what Travel is, it's a facility that's dedicated to the advancement and research and education of human-centric behavior and interaction with transportation systems. We primarily do that through virtual and naturalistic studies. My primary focus is generally in simulation studies themselves, and what we're really focusing on is the convergence or integration of multimodal data, human-centric multi-source data sets to understand user behavior on the roads. So what we have here at Travel, we have a driving simulator, which you can see as our cave simulator over here. It's a 360-degree cave, 6-degree of freedom platform. We have a mini sim driving simulator, which is in the back. It's a single screen display, but we have also integrated that with mixed reality and virtual reality technology. And where my expertise particularly lies is in vulnerable road user safety and behavior. So we also have a bicycle simulator that I had developed in my PhD and now have redeveloped as a professor at UB, and a pedestrian simulator as well. So both of those can be integrated into mixed and virtual reality to study many different types of real-world applications, whether this be for developing like a digital twin of a real-world location or testing out new roadway designs and technologies prior to deployment.
Thank you. Yeah. Thank you, Austin. So with that capability and with the access we get from Mcity last year, what we want to do is integrate them together with all the different modality of simulator. We want to achieve safety analysis. We want to do safety analysis using all this mixed reality. Basically, we try to do unsafe things in a safe way. So how do we do that precisely? Imagine the cases where we may have human interact with connected automated vehicle, and we really want to see if certain safety critical events could happen or not. We definitely don't want to put them into the same space in case something were to happen. And we also don't want to skew the results where they have the additional safety concern when they are interacting with each other. So we really want to have the fidelity to trigger some unsafe event, but both parties still stay safe during the interaction. So how do we do that? Leverage with the capability we have at Travel, we can bring in multiple capability of a multiple level of human interaction with autonomous vehicle, but all in a safe way. We have, as Austin mentioned, different driver simulators, different fidelity. One is maybe more engaged than the other one. We also have cyclists. We also have pedestrian. Now, these are all remotely from Mcity. But if we can bring them to Mcity, interact with each other, then this would give us the safe and credible testing environment. So how exactly we do that? We leverage Mcity's resources at two different levels. We first start with integrating all these agents in the Mcity digital twin. With the infrastructure established by Mcity, as long as we have the simulator doing the proper thing, they can, through Mcity, interact with each other in the Mcity digital twin, creating the first level of mixed reality where they interact with each other. Now, in this case, it's mostly human-to-human interaction. We can bring in some algorithm way to simulate some of the vehicle, but this is still largely happen at the digital twin level. Once we are able to do that, with the infrastructure at Mcity, which presumably a seamless connection between the digital twin and the real world, we can achieve the second level, the second object, integrate all these agents as part of the mixed reality. In that case, we really bring the virtual present of all these simulators, but actually physically on track. And on top of that, we can have any of these simulators, human-driven, real human in a loop simulator to actually interact with a real autonomous vehicle or any other real participant on the road. Either it's a human driver interact with the Lincoln, the real vehicle on the track, or the other way around. The Lincoln is, someone on the track is interacting with another human driver, but calling virtually into the Mcity environment. So this is what we really want to achieve. And we want to come up with test scenarios for each, tailored to each of these simulators to actually test safely for the human and CAV interaction. So any questions at this point? Okay, so let's start to dive into some of the actual scenarios we are interested in. And both of us will introduce some of the relevant scenarios for us. For me, I focus mostly on human driver and the autonomous vehicle interaction. So there are highly interactive scenarios between human-driven vehicles and autonomous vehicles. For example, I showed two of these cases. One is on a uncontrolled, unsignalized interaction, very common in rural areas. You may have stop sign, you may have, or you may not even have stop sign. But in this case, you may have cases where the driver need to virtually negotiate with others. Now, drivers are thrived in this scenario, but CAVs or autonomous vehicle not necessarily. So how do we design scenarios where the human interact with the autonomous vehicle that act as a human driver? And we want to be able to leverage the testing scenario such that the human does not necessarily know whether it's interacting with a real human or with an autonomous vehicle. That way, if they cannot differentiate the two, then we have a good design. So that's one of the scenario, interactive scenario. The other scenario is a merging case, which is more common in highway, where the two vehicle has to negotiate who go first and next. And right now, as of today, most of the connected automated vehicles struggled with this scenario simply because they're too conservative. It doesn't really behave as a human. Now, with the capability, these are the scenarios we want to test, where, again, the human driver would interact with connected automated vehicle without necessarily telling which one is the connected automated vehicle, then we have a successful case. We want to be able to have the connected automated vehicle behave safely, but also act like a human. And the capability we have allows us to do this. Okay, so next I will go to some other scenarios.
Yeah, so as I was mentioning before, my primary interest is really in vulnerable road user safety and behavior. And this opportunity has provided the perfect chance to be able to do many of the unsafe things in a safe way, as we've mentioned here, for the first time. And what I really want to do, and what I've been wanting to do for years, is understand how we can influence and change autonomous vehicle behavior based off of the feedback from people on the road, vulnerable road users, the people who are most at risk. Pretty much every single autonomous deployment that we've had in the US has resulted in some sort of fatality or crash, severe injury with a pedestrian or cyclist. It highlights for certain that there are issues in understanding how those vehicles are supposed to behave around cyclists and pedestrians, but also how cyclists and pedestrians are supposed to behave around them. So this offers a really nice opportunity to be able to study mid-block crossings, lane passing behaviors, to see how we might want to change autonomous vehicle behavior in those instances. So, for example, one of the major and most simple scenarios that we can test is overtaking a cyclist while traveling down a road mid-block, so not at an intersection. How close should the autonomous vehicle actually pass a cyclist? Well, we don't actually know, and we've never been able to really know because we don't understand cyclist comfort. But being able to study this with the real vehicle on the test track and a cyclist in virtual reality, but experiencing the closeness of the vehicle, we can actually test safely for the first time what that comfort actually is. And we do this not only just by behavior and stated preference feedback, but we're integrating physiological feedback as well. So heart rate, stress, eye tracking, where are people looking, what is their pupillometry? It's one thing for someone to say, hey, no, I totally felt safe in that scenario, but if I see that their heart rate spiked like crazy and their pupils dilated, I know that they're lying. So this is very, very helpful information for us to understand, well, what are the actual vehicle dynamics that need to happen? And then we can take that a step further to change the vehicle behavior and or create new technologies in order to let pedestrians and cyclists know what that vehicle is actually doing. So providing intent in the future. Pedestrian gap acceptance and autonomous vehicle behavior at mid-block crossings. This is a very difficult scenario to understand, whether or not there are actual infrastructure improvements at an intersection, like rectangular rapid flashing beacons or not. The negotiation between a pedestrian and a vehicle is already difficult. We're already looking for eye contact at many of those locations. And if we have an AV, there's nobody usually at the seat, or ideally there's no one at the seat. So we need to figure out how that vehicle is going to behave around pedestrians so that they understand when to cross, but also understanding how pedestrians cross and what their behavior is so that the AV can respond appropriately. How good is it at detecting when someone is going to actually cross the road or when someone is maybe 2 lanes away from them in a larger mid-block crossing while they're going across the road, so does it need to slow down and stop? And it's one thing to do this in virtual reality and come up with an AV and simulate an AV in the environment, but that's highly controlled. We know how that vehicle is going to behave. So using an actual vehicle on a real track with someone that's being virtually projected onto the track from VR into like a dummy, let's say, crossing a track, we can actually understand the real vehicle dynamics in those scenarios and understand how good they are at actually picking up pedestrians and behaving safely. Another scenario, too, that we're really interested in is bicyclist and AV intersection negotiation. So for those of you who have maybe not ridden a bike, intersections are not the safest place for cyclists in general. And it's also a very uncomfortable scenario as well. Many states have started adopting what is called the Idaho stop, or the California roll, as many others call it too, which is a not actual stop. Cyclists are allowed to pass through stop signs without actually dismounting because it's actually safer for cyclists to do that. Well, how does that negotiation even happen with an AV? What if an AV is stopped and then starts to go and the cyclist starts going through the intersection? How is that interaction going to go down, and how do we change AV behavior to make that even safer? And are they even good enough at noticing when a cyclist is doing that kind of behavior as well? So these are all really, really simple but very important scenarios to start understanding so that we can improve AV behavior in the future. Do you want?
Yep. So thank you. I think Austin and I have tried to iterate 2 things, just to quick summarize. One is that we actually bring human in the loop that testing with actual AV that would actually see each other, but in the virtual space, so we are safe, but preserve the real interaction. And we can test all those small nuances, scenarios for safety, for behavior analysis. And second thing is, this is only enabled by the fact that we have this virtual world connection where we simulate the scenario in one places, and Mcity actually bring in the real vehicle, which most of the school, including UB, doesn't have, to actually be interact. Now, to report the stat, how are we, in terms of achieving that, I try to summarize with this relatively busy slide. Let me try to walk you through. So this is one of the scenarios that I'm interested in terms of human driver interacting with the real vehicle. In this case, we would want this white vehicle to be projected to our simulator as the actual percent of either the Lincoln, which is the first case, or it could be another simulator, presumably a human-driven, or maybe some algorithm-controlled player, just like an agent. So the human, when driving and interacting, like myself, interacting with this vehicle doesn't necessarily know which vehicle it is actually interacting. But because we are communicating in the virtual world, we can replicate some of the real behavior of the autonomous vehicle. So this different modality allows us to understand how human may react differently to different player. And on the other hand, if we can improve the algorithm of the AV through this or through the actual vehicle, we can achieve the level of negotiation or behavior that is very similar to the actual human from both safety and efficient perspective. Now, where we are right now, we established successfully the simulator between the simulators inside Travel Lab or on UB campus through the Mcity cloud. So now, seamlessly, all the simulators can call in and do any of the interaction that we want. We are in the process of solidify a simulated agent, which, based on our design, should be able to influence human better. And we also in the process of integrating the test vehicle interaction with the actual Lincoln on the road. All this through the same channel of Mcity digital twin infrastructure should provide a seamless interaction with the local simulator that doesn't really tell the difference. The other thing I want to highlight from this slide is to mitigate any technical issues with latency and so on, the simulator rendering is dialed down locally. So when we say we are interacting with the remote vehicle, all these environments are actually rendered locally. We are not heavily rely on any communication. We only transmit those necessary information to mitigate the latency. And similar to the vehicle-to-vehicle interaction, with the pedestrian that Austin was saying, we are also making similar progress. We also want to interact with real vehicle and other simulator. We're pretty much done with the simulator, but we are in the process of negotiating and see how we can actually interact with the real vehicle on the track. And we hope we can do that in a reasonably short period of time, so we can actually start testing any of the scenarios that we mentioned before. Okay. I think that's pretty much the status we have. Like we have summarized or already alluded to, some of the next step is we want to optimize those agent information flow to make sure the actual simulator interaction between the real vehicle will be seamless. And we will do a real quick gap analysis in the near future with Mcity to test how far are we in terms of actually communicating and interacting with the real vehicle on the Mcity track. And we are in the process of, like Austin mentioned, connecting the pedestrian platform with the actual simulator to be able to interact the same way as the vehicle, and same thing to the bicycle simulator. And we are now in the process of solidifying those scenarios that we described for the actual test we want to do in the summer-fall timeframe. And I think with that, we would like to conclude this part with some of the reference. Probably a little bit heavy to show this, but glad the slides will be shared and be able to answer any questions if there are. Thank you very much. Yes.
Oh, thank you. Just a quick question about the complexity of the situations you guys are looking at. Of course, you showed some cases where a vehicle is interacting with a vehicle with a cyclist. In the real world, I think often the challenge happens when there are multiple players. So could you elaborate a little bit? How would you handle those, and are you interested in that?
Yes, so I think I will say first, and if you have comments. So we're definitely capable of scaling up to multiple agents interaction. Right now, we want to start with just 2 agents to isolate the problem. Technically, we have the capability. Now we allow multiple simulator to be called in the same time. We actually can have multiple agents. And you're right. That's where ultimately we want to test. And we believe with Mcity's infrastructure access and with our design, we are capable of doing that. So I think, as we alluded to here, so we actually already capable of bringing multiple agents to interact with each other. But we just have to design in those scenarios more carefully the scenarios. You want to add something?
Yeah, I mean, another challenge I'll just say too is, we can have multiple different drivers inside of the same test track at the same time, right? But even having 3 vehicles, a pedestrian and a cyclist, only comes 10% as close to what you would sometimes see at some busy intersections. So being able to also include simulated vehicles inside of those environments as well would be very, very important. And that's been a challenge in simulation for years, at least when we're doing human-centric kind of studies. That's something that we can do. We already do that inside of like virtual reality studies. But bringing it in here will actually be a very interesting challenge too, because having real vehicles spaced out with fake vehicles essentially will be a very interesting scenario to start developing. Ideally, we want that too, because we don't want to have 30 different people driving vehicles in the same space at the same time at some point too. But yes, it is a highly complex problem, but we're developing the platform, and I'm very, very optimistic about that. So, yeah.
We also have a question online from Toyota.
Yeah.
Oh, there are people online.
Sergey, you want to go ahead?
I also have a question, if you don't mind.
Yeah, go ahead.
Oh, hi, Chaozhe, and hi, Austin, if you can hear me.
Yes.
Yeah.
Now, I heard that negotiation between cyclist and vehicle, as well as this notion of intent sharing, was brought up a few times. I was wondering, could you dive into a little detail about what do you mean by intent sharing and what do you mean by negotiation?
Yeah, absolutely. So especially when looking at intersections where you are looking for communication between different agents and different modalities, there's a couple of different ways to go about intention. You can go all the way down the road to very smart technologies where people's trajectory is being shared, and that could be transferred in between users so that people, driver or an autonomous vehicle might understand where a cyclist might be going if they have a navigation system. So that would be a direct smart communication on a one-to-one there. But in terms of negotiation, there's many different ways to talk about or sharing intent. I'll start with that first. There's many different ways, like EHMIs, as another, or external human-machine interfaces is another opportunity that we can start leveraging to have a vehicle somehow tell the cyclist that they're recognized, or tell the cyclist it's okay to go through the intersection, or that it's yielding for them. Those are all different types of scenarios that we can test in these environments as well. So having a real AV that might be able to recognize the vehicle in the first place and then be able to provide some sort of information to them could be very helpful. We're actually even working on some studies right now too with augmented reality cyclist heads-up display units, so that if there was an AV at an intersection that was yielding for them, it could automatically send a message to a cyclist saying that it's yielding or just stopping. So there's many different ways to provide that sort of like intention, and those are very advanced ways of doing it. But we can talk more about that. But yeah. Here.
Yeah, so thank you. Thank you, Sergey, for that question. Complementary to what Austin said, I want to comment on the intention identification process. For example, for this case, this study between human driver and the actual autonomous vehicle, what we are interested in is whether using this platform, when we actually have human in the loop, can we identify some model about the human where we can actually model their intention? And this intention can then be incorporated in our planning. So this negotiation doesn't necessarily happen in a shared way, but really as if the autonomous vehicle have some kind of human intelligence to negotiate with the humans. We want to gain that capability through this. And we think we are in a unique position because this platform allows us to test the human or validate or at least gather data about human behavior in order to model how human would express their intention or show their intention. So this is the research of the intention, that one perspective we want to go. So hope that gave you some perspective.